I'm Ken Andrew with Non-Line of Sight Wireless, consultant for RF data links. This video series is about what I can do to help you get your unmanned air vehicles, UAVs, or ground vehicles to market and have the flight range or the ground range you expect. In video number 1, I cover who am I and some major issues through RF interference. In this video number 2, I cover 2 other main issues that limit the data range. If you don't need this level of detail, just jump to video number 3, where I do a review of major issues, few details, and I talk about a program to train your customers and staff that will really increase sales. Before I started consulting, I was a sales field engineer for a major data link OEM. Many of my UAV, UGV customers spent anywhere from 6 months to 2 years in R&D, up to the point of starting production. Then they go buy a data link from me or someone else that gave them 50 to 80% of the range. And of course, that didn't work because they couldn't sell the product, so it zeroed sales until they got these things fixed. So I ended up going to the field to fix those problems. And one of the things I found right away is the customers weren't doing bench testing of their data link modules. This seemed kind of strange to me, as no one installs a new gas or electric engine on a UAV or any platform without stress testing on the ground. Why don't they test RF data links? Usually that's for lack of staff and RF expertise, and rarely a complete suite of quality RF test equipment. So what do you need for RF bench testing? Start with a real-time spectrum analyzer with 1 part per million time base that doubles as a counter, and a peak and average power meter that can see short packets. This power meter needs to be 0.07 dB accurate. Then a programmable microwave signal gen, and a programmable step attenuator, and a short list of calibrated RF accessories. This list, plus training on the front panel and test equipment procedures, makes it useful. Today I find many of the data link OEMs barely meet their own specs. They're really getting sloppy. When I configure their modules for high data rate to pass what everybody really wants, which is HD video, it can be off 4 to 6 dB. That's really bad range, usually about 50%. Once I RF bench test a module, I can usually design around a working system that will solve some of the problems. Surprising to me, almost all RF data links modules, good or bad, are identical unit to unit. Go figure. In most cases, I can add more antenna, more biamp gain, somewhere in the system to use that low-cost RF module. I see why some UAV, UGV OEMs go quickly to a third-party external biamp supplier to fix their range problems. If they use the 1 watt module and they only got 50–80%, why wouldn't you jump to an external module and get 5 watts out? So for several years I worked with Triad RF, one of those major biamp OEMs who has many customers and still does, who bought their biamps, and they still have little success. One major problem Triad and I found is that their customers don't have the test equipment. We found in most cases they were overdriving their new biamp and getting about the same poor range after spending thousands of dollars and weeks and months of R&D time. So I trained them on how to properly configure the data link and the test procedures to use accurate peak and power meters that they need to purchase. Then they go out and spot the overdrive problems on the biamp, and they get the kind of range you expect. So bottom line is, you can't paste an external biamp onto an RF data link, not knowing the data link RF output within 0.5 dB, then know the data link modulation type, the biamp manufacturer's drive spec for that modulation type. Otherwise, you cause a biamp to have output distortion and you'll get the poor range. So what's learned here? So no one would expect a race car to perform 100% out of the box. If the race car doesn't perform max output, you don't put it on the track. It's no way to troubleshoot because you need the instrumentation to find the problems. So flight testing is the last check and not a method to do R&D. This can be a huge time waster. You can do 100% accurate range tests, solve all your RF problems, including antenna patterns, fix the internal RF problems from the data link on the bench, and then when you do the flight test for a one-time final verification, you do that while you're making a new sales demo because you got 100% of the range. So this is the end of video 2. See video 3 for an overview and training for your staff and customer staff and increase sales. Until next time, Ken Andrew, Non-Line of Sight Wireless.